same direction. In element B, right, the torque is generating in so-called anti-clockwise direction, but the shear flow is generating in a what? In a clockwise direction. Okay, so therefore element D has the highest acting, okay, sorry, element D has the highest, right, highest shear stress induced by both torsion and shear force. Okay. So now we know, going back to our element, the second element that you have to test is element D. Okay, we just found that element B is not the highest. Now, this is where we have combined all the loadings. Yes, right? We combine all the loadings now. Okay, we analyze axial load, bending moment, torsion, and shear. So now the next thing is, how are we going to select the material, or how are we going to select the right diameter? Okay. So now, so based on our elements, so from here, right, with all these formulas over here, right, with all these formulas over here, right, formula, okay, with all this formula over here, you are able to calculate the normal stress and the shearing stress acting on the element. So the next thing you'll do is you're going to construct the element with the associated stresses. Okay, so now you are ready to construct the element. Okay, wait. So it is a 3D problem. You construct an element in 3D. This is just an example. Okay, so you will have your, so I'll call this my I'll try to make it so that it's relatable to the problem that we have. I think that's better rather than draw something. So this is our element D. Okay, this is our element D. So if I were to draw our transformation, this is X, this is Y, and this is Z. Okay, so we know that we will have normal stress in X, compression, right? And then we have shearing stress. Okay, so we have shearing stress going this direction. Okay, so this is a 3D element. So the normal stress in X, we know that we can calculate the based on Px over A, right? Plus by Mz over Izz multiplied by Y. And the shearing stress over here is equal to TR over J plus by VQ over IT. Okay. So now the next thing we draw is we're going to draw mole circle. Okay. So we are going to, from here, we are going to construct 3D mole circle. Okay. We're going to construct 3D mole circle. So I'm going to call this plane over here. I'm going to use a different color. Okay. So I'm going to call this our X. Right. This is our Z. And the surface below is our Y. Okay. So we are going to construct 3D mole circle now. Okay, we're going to construct 3D mole circle now. Don't worry, we are almost coming to the end on how to design a structure, how to determine a structure. Okay. And these are the things that you will learn. Okay. So now we're going to construct 3D mole circle. So this is your normal stress. This is your shearing stress. Element rotate clockwise. Element rotate anti-clockwise. Okay. And then we are aware that the normal stress in the x direction. So our stress Z and stress Y are equal to. So our stress Y and our normal stress Z are all on the zero line. We have zero normal stress on point X and Z. Okay. Then we are going to construct our shear, our normal stress. Okay. So this line over here is our stress X. Okay. And we know at point Y is exactly at the center over here, because point Y have zero shearing stress and zero normal stress. Okay. Now the thing is point X. Okay. So at point X, so I'm going to draw our element in this orientation now. Okay. So this is our X, and this is our Z. Okay, so when I draw it, this will be our stress X. Okay, and yeah, is very late now, so I can make mistake. So if I were to flip it over there, this will do this direction. Okay, so this is my point X, and this is my point Z. Okay, and then they have shear stress. Okay, so they have shear stress. So I'm going to, for simplicity's sake, I'm going to put this over here. Okay. Then from here, we know that we have a shear. Okay, so hold on. So we have shearing stress. So this is our shearing stress magnitude. Okay, so we know that at point X, the element is going to rotate in a clockwise direction. Okay, so clockwise. So this is our point X. And the other one, our Z, this will rotate in an anti-clockwise direction. This is our point Z. So now we draw our line. Okay. So from here, we can draw one of our mole circle. So this is one of mole circle. Okay. Now this is 3D. Okay. And I'm going to show you 3D mole circle is not that difficult. Okay. So this is one of our circle. Okay. And then there are two more other circles. So this is known for our circle. This is our XZ plane. Remember, all these are in 3D. Okay. And then we can construct another circle. Don't worry now. I'm just demonstrating what you or showing what you will learn. Okay. Later on, you can construct this easily. Then the next one, this is our circle for our YZ plane. Okay. And then the final circle that we will draw. Okay. So our final circle is this circle over here. And this circle is for our it's too late at night for me, XY plane. Okay. So what are we trying to determine down here? Okay. So we are wanting to find out these 2 points. So this is our stress 1 from our analysis. Over here, this is stress 2 of our analysis. Okay. What we realize about stress 1 and stress 2 is that they are known as principal stress. And in the principal stress, the shear stress is equal to what? 0. Okay? The shear stress is equal to 0. Now, you have seen this before. Where? Over here. Over here, we also know that what is given to us are principal stress. And from the principal stress, we realize that the shear stress are also equal to what? 0. What I'm trying to say down here, we normalize how the material or how, okay, we normalize how the material which are carried out in tension, compression, or shear, we normalize the direction. Normalize means it does not matter now. Why it does not matter now? Because what we plot down here, okay, so this is material behavior. This is material property, yes? We plot at where shear stress is equal to 0. Either in tension, compression, or shear, your principal stresses, the shear stress is equal to 0. Now, we go back to our structure over here, right? Stress 1 and stress 2, okay? The shearing stress is also equal to what? 0. Okay, so in order to select the material now, okay, in order to select the material now, we have to ensure that the stress 1 from the analysis, okay, is less than the stress 1 of the U. Okay, right? Because the stress 1 are all your what? Principal stresses. So that is where you can normalize the direction of how the test has been carried out or how the structure has been carried out. So let me elaborate a bit more. Okay, what I'm trying to say is this. Okay, I hope I want to sound this clear. Right? We are given, right, the properties in uniaxial tensile and the properties of uniaxial or shear test only. Our structure is not loaded that way. The only common feature over here is both of them, right, have principal stresses. Okay, so from this table, right, I highlight to you that this table, what is given to us is principal stress. In order to select the right material or the right diameter given the material, you have to analyze the what? At the end of the day, you have to compare the principal stress. Are we clear? Okay. So what I've explained to you in a nutshell is what you're going to learn from week 1 to week 10 or 11. Okay. Then after that, we're going to do other topics like buckling. Okay. So this is the overall view. So in order to do this subject well, you have to every week write summary sheet. Okay, whatever I teach, you have to generate a summary sheet. And next week, I'm going to teach a first topic, or not next week, Thursday. Okay, I'm going to teach bending moment. And at the same time, I'm going to teach you how to write a summary sheet that will be useful for all of you, okay, in this course, so that you don't feel overwhelmed. Okay, so on that note, that's all I have now. Amara, I will talk to you after this class. Okay, so anyone that have question, please